Ohm's law. So Ohm's law is a relation between the potential difference and the current in a conductor. So it shows the relationship between, Ohm's law shows the relationship between potential difference and current, potential difference across and current through a conducting wire, a conductor. So in order to understand the relationship between these two, let's do an activity. So in this activity, the circuit shown in the figure has to be set up, and according to this, first we will be using a nichrome wire, and we'll be connecting the nichrome wire in a circuit as shown in the figure. So this nichrome wire is an alloy of nickel, chromium, manganese, and iron, and it has some peculiarities, and we will learn about it in a later video. So in this experiment, for this experiment, we'll be using some cells. As we can already see, there are 4 cells which is connected, and they have shown this dotted line to show that these are connected one by one. So at first, when we start the experiment, only this will be connected. So only the first cell will be connected when we start the experiment. And we have this nichrome wire, and we have an ammeter connected so that we can measure the current, and we have a voltmeter connected across the nichrome wire so that we can measure the potential difference across the wire. And there is a plug key which is connected in the circuit. So let us see first when we connect only the first cell. So first cell is like 1.5 volt. We are connecting only the first cell. That means the voltage we are providing is 1.5 volt. And then there will be some current that is flowing through the circuit. We'll measure that current by using this ammeter, and we will measure the potential difference that is across this nichrome wire. So by using this voltmeter, and we plot these two values in the graph shown here. So after plotting, we have the values for current and the voltages or the potential difference across the conductor. Now, after that, we are going to increase the value of this voltage provided input voltage. So for that, we are using a second cell also. So here there is the second cell. So next time when we connect, it will be like we'll be connecting like that. So now the effective input voltage will be 1.5 plus 1.5, that is 3 volt. Like that, again we will measure this current by using the ammeter, and we will measure the potential that is dropped across the conductor using the voltmeter. So like that, we measure it for different values of input voltages. Like we'll go from one cell to finally we'll connect 4 cells so that we can increase the current, and according to that the voltage is also plotted. So by plotting that, we will get a relationship between the potential difference and the current through the conductor. So that relationship is plotted and we get a graph as shown in the figure. So there is this potential difference in the y-axis and current in the x-axis. So from this, we can see that it is having a straight line. It's showing a straight line for this particular experiment. So this is the graph, right? So this shows that it is a straight line. What does it mean is like the division of like the ratio of V and I, that is the potential dropped and the current through the conductor. That ratio is a constant. that ratio remains a constant. So there are some little bit variation somewhere, but mostly when you see all these values are constant. That means V by I is a constant. So this is the relation that we call as Ohm's law. So it was found by a German physicist, George Simon Ohm, and he found that the relationship between the current I and the metallic wire and the potential dropped across the metallic wire is a constant. So from this we can write the relationship as we can write it as V divided by I is a constant. This is Ohm's law. Or we can say V is directly proportional to I. That means if you increase the current, through the conductor, the potential difference dropped across the conductor also increases. That is what V is directly proportional to I. Or we can say V by I is a constant, and this constant can be represented by a symbol called R, and we call it as resistance. So V by I equal to a constant, and that we call as resistance. So this constant R is called resistance, as we know, and this resistance is the same for a particular conductor at a particular temperature. So if you increase or decrease the temperature, this can vary. Otherwise, at a constant temperature, V by I is equal to R, and this R remains constant. So no matter how if we increase the current, the voltage also proportionally increases, and because of that this R remains constant, and it is a property of the conductor. So it does not vary according to the current provided or the voltage dropped. So according to Ohm's law, what we can write is V by I equal to R. And we can define R is equal to V by I, and this R is the R has a unit ohm. R has as a unit ohm, and it is represented by this symbol. And we can define 1 ohm from this relation. We can define 1 ohm. So 1 ohm equal to 1 volt divided by 1 ampere. So in the previous video, we saw the symbol for a particular component, electronic component. We saw that there is a symbol like this, and we have an arrow that is coming from the top, and this is the symbol for a particular component. We called it as rheostat. So rheostat, we told that it is a variable resistance, right? So this variable resistance is a way to control the current, so without varying the input voltage. So if you don't want to change the voltage source, like here we are adding voltage, keep on adding voltage source if you want to increase the current, right? Instead of that, we can keep this voltage source a constant, and we can include this rheostat in the circuit. And when you vary the rheostat, what will happen? When you vary the rheostat, the value of the current in the circuit is going to vary. So resistor can also be used to vary the current flowing through a conductor. So if you add more resistance, what will happen? Resistance is inversely proportional to the current. So mm, or reverse also, the current is inversely proportional to resistance. So if you add more resistance, the current through the circuit will also reduce. So this is all about Ohm's law.